In the previous section, we learned about conditional statements. We learned how a program can make decisions using conditions like if, else, and elif. Now we are going to learn one of the most powerful concepts in programming, loops. Before understanding loops technically, let's understand the problems loops solve. Imagine you are working in a company and your manager asks you, send a welcome email to 10,000 new customers. Now imagine writing the same email code 10,000 times. It would be impossible. Or suppose a teacher wants to print the marks of 100 students. Would the teacher write 100 separate print statements? Of course not. This is where loops become useful. A loop allows a computer to repeat a task automatically. Instead of writing the same code again and again, we write the instructions once and tell Python, repeat, repeat this work for me. This saves time, memory, development effort, and reduces mistake. Why do we use loops? There are mainly three reasons. Number one, repetition. Whenever we need to perform the same action multiple times, we use loops. Example, printing number from 1 to 100. Number two, processing data. In a real world applications, we work with huge amounts of data. For example, an online shopping website has millions of products. A social media app has millions of posts. A bank has millions of transactions. Loops help us process this information one by one. Number three, automation. Loops are the foundation of automation. A company can automatically send thousands of emails. A program can automatically check thousands of files. A system can automatically analyze large data sets. Types of loops in Python. For loop. A for loop is used when we know how many times we want to repeat something. Example, print the name of 15 students. We already know the number, so it will print. So the second type is while loop. A while loop is used when repetition depends on a condition. For example, keep asking the user for a password until they enter the correct one. We don't know exactly how many attempts the user will take. Simple understanding, think of a loop like a washing machine. You put clothes inside and choose a program. The machine repeats, add water, wash, rotate, rinse. You don't manually repeat every step. The machine does it automatically. A loop works the same way in programming. Now let's understand the first type of loop, the for loop. A for loop is mainly used to iterate through a sequence. What is a sequence? A sequence is simply a collection of multiple items. Examples: list of students, list of products, character in a word, number in a range. So here we have an example. Here we can see that the students is equal to Aisha Ben Kara. For S in students, print hello S. So if we write this, the output will be this: hello Aisha, hello Ben, hello Kara. This list contains three names. This means take each element from the students list and store it temporarily in the variable S. The loop automatically stops after all elements are processed. Important concept, iteration. The process of going through each item one by one is called iteration. So when we say the loop iterates through the list, it means the loop visits every element in the list. Now let's learn the second type of loop, the while loop. A while loop repeats as long as a condition remains true. Let's see an example. Here we can see count is equal to 1. Here is the example. Python checks is count less than or equal to 3. Yes. So the output will print 1. Okay, so count becomes 2. Then again the condition is checked, then it will print 2. Count becomes 3. Now it will print 3. Okay, here we can see the output. Now count becomes 7, but 3 is less than 4, right? The loop stops, it means false. Real life example. Okay, imagine a login system. The program says enter your password. If the password is wrong, try again. It continues you until you use the correct password entered or the user chooses exit. This type of situation is perfect for a while loop. Difference between for and while. Let's quickly compare. For loop use when you know the number of repetitions. Example print 100 numbers. While loop is used when you don't know how many repetitions are required. Example keep asking until the user gives the correct input. Both loops are different important and professional programmers use both depending on the situation. Now we understand how loops work normally. But sometimes while running a loop, we need more control. For example, imagine you are searching for a particular student in a list of 1000 students. Once you find that student, do you need to continue checking the remaining 999 students? No. You can stop the loop immediately. Python provides three special statements for controlling loops. Number 1, break. Number 2, continue. Number 3, pass. Let's understand them one by one. Number 1, break statement. The break statement is used to exit a loop immediately. Let's look at an example. For n in range 1, 6, if n is equal to 3, break, print n. So the loop starts for first value is n is equal to 1. Condition is n equal to 3. No. Then it will print 1. Second iteration n is equal to 2. Condition will be is n equal to 3. No. Then it will print 2. Third iteration n is equal to 3. Condition becomes true. Python executes break. The loop stops immediately. The output is 1, 2. Notice the 3, 4, 5 are never printed. Real life example of break. Imagine you are working for a specific book in a library. You check books one by one. The moment you find your book, you stop searching. You don't continue checking the remaining books. That is exactly what break does. Okay, so I think it will be clear for all of you. So, number 2, continue statement. Now, let's understand continue. The continue statement does something different. It does not stop the entire loop, it only skips the current iteration and moves to the next one. Example for n in range 1, 6, if n is equal to 3, continue, print n. Execution. Okay, so firstly n is equal to 1, it will print 1. N is equal to 2, print 2. N is equal to 3, condition becomes true. Python sees continue. So it skips printing 3, then it moves to n is equal to 4. It will print 4, then n is equal to 5, it will print 5, then the output will be 1, 2, 4, 5. Okay, so real life example of continue. Imagine processing employee records. Suppose you are calculating salaries. One employee's data is incomplete. Instead of stopping the entire process, you skip that employee and continue with others. That is where continue is useful. Pass statement. Now let's talk about pass. Sometimes while developing software, we create a structure but don't want to write the code yet. Python does not allow empty blocks, so we use pass. For example, for an I in range, so here for n in range, in bracket we have 3, then pass. Here Python does nothing. It simply moves forward. Real life example, imagine you are planning a building. You draw the rooms and structure first, but some rooms are still empty because construction hasn't started. The pass statement is like leaving a placeholder. Later you can add the actual code. So let's have a quick revision. Remember, break is used to stop the loop completely. Continue, skip one iteration. Pass, do nothing temporarily. These three statements give programmers better control over loops. So now let's learn a slightly advanced but very important concept, nested loops. The word nested means something placed inside something else. So a nested loop means a loop inside another loop. Why do we need nested loops? Let's imagine a classroom. Suppose there are 3 rows and 4 seats in each row. If we want to visit every seat, one loop is not enough. We need one loop for rows and one loop for columns. That's exactly a nested loop. Example 1, multiplication table. Let's look at this code for I in range 1, 4 for j in range 1, 4. Print I into j. Okay, here we have two loops. The outer loop controls the first number. So the outer loop controls the first number and the inner loop controls the second number. Execution. First I is equal to 1. The inner loop runs 1 into 1, 1 into 2, 1 into 3. Then I becomes 2. The inner loops runs again. This continues until all combinations are completed. Example 2. Seating rows. Suppose a cinema has rows and seats. Rows is equal to 2, column is equal to 3. For R in range rows, for C in range columns, for print seat R comma C. So here the output will be seat 0 0, seat 0 1, seat 0 2, seat 1 0, seat 1 1, seat 1 2. This type of logic is used in games, maps, images, and matrices. Example 3, pairing items. Suppose we have 3 students A, B, C. We want every possible pair. Nested loops can generate A, A, B, A, C, B, A, B, 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 C, and so on. This is useful in recommendation systems, comparing products, and data analysis. Important warning, nested loops are powerful, but they can become slow if used incorrectly. For example, one loop with 1,000 items is okay, but a loop inside another loop with 1,000 items means 1,000 into 1,000 operations. That's 1 million operations. So, professional programmers use nested loops carefully. Now we are moving to another extremely important concept, functions. Functions are one of the biggest reasons why programmers can build large applications. Let's understand the problems first. Imagine you are writing a banking application. You need code for checking balance, depositing money, withdrawing money, transferring money. If you write all code together in one huge file, it becomes difficult to manage. Instead, we divide the program into smaller blocks. These blocks are called functions. What is a function? A function is a reusable block of code designed to perform a specific task. Think of a function as a machine. You give it input, it performs an operation, it gives output. Real life example, think about a coffee machine. You press one button inside the machine, many steps happen. Add water, mix coffee, add milk, prepare drink. You don't need to know every internal step. You simply use the machine. Functions work the same way. Advantage of functions: code reusability. Write once, use many times. Better organization. Large programs become easier to understand. Number 3, easier debugging. If something goes wrong, we can check one function instead of the entire program. Built-in and user-defined functions. Python already provides functions. Example, print, length, input. These are built-in functions. We can also create our own functions. These are called user-defined functions. Now let's create our own function. The keyword used to create a function is def. It's define. Okay. So let's understand. Define tells Python I am creating a function. Okay, and greet. Greet is the function name, and name, it is the input. Inside the function we print the greeting. Now we call the function greet Sam. So the output will be hello Sam. Hello Sam. The function executes whenever we call it. Function with return value. Now let's see another example. These functions take two numbers, it adds them, then returns the result, then calling. Result is equal to 8, 2 comma 3. Now result is equal to 5. Why return is important? Imagine a calculator. You don't just want the calculator to display the answer. You want to use that answer somewhere else. Return allows us to store and reuse results. Now let's understand two terms that confuse many beginners: parameters and arguments. Parameters are variables written when creating a function. Example, define greet message. Name is the parameter, it is like a placeholder. No, sorry, message. Message is a parameter, it is like a placeholder. Arguments. Arguments are the actual values we provide. For example, greet, welcome. Welcome is an argument. So, understanding scope. Now, let's discuss scope. Scope means where can a variable be accessed. There are two main types: local variable, create inside a function, available only inside that function, and global variable, create outside functions, can be accessed throughout the program. For example, here we can see that x is equal to 5, define f, x is equal to 2, return x. The x inside the function is different from the function x inside, outside. They are separate variables. Understanding scope prevents many programming mistakes. Okay, so now imagine you want to store information about thousand students. Creating thousand student separate variables is impossible. That's why Python provide collections. Collections allow us to store multiple values together. Python has four important collections. Number one list, number two tuple, number three set, number four dictionary. Let's understand them. A list is ordered, mute, changeable, allows duplicate. Example student names. You can add or remove students anytime. You can add or remove students anytime. Tuple. Tuple is ordered, cannot be changed. Example coordinates, latitude and longitude. These values usually don't change. Set. A set stores unique values only. Example removing duplicates email ID. Dictionary. A dictionary stores data as keys value. Example student ID has marks, employee ID has salary. This is similar to a real dictionary. Word meaning key value. Finally, let's discuss the most commonly used collection, the list. A list allows us to store multiple items in one variable. For example, here you can see fruits is equal to apple, banana, cherry. Here we have three values stored together. So accessing elements, Python uses indexing. Important, Python indexing starts from 0. So index 0 means apple, index 1 colon 3 means banana, cherry, slicing. Okay, so here we comes to sign. Sorry for the mistake. Okay, slicing means taking a portion of a list. Okay, for example, fruits 1 colon 3. This gives banana and cherry. Adding items, we use append. Now that the list contains, here we have append date. So now the list contains apple, banana, cherry, and date. Removing items, we use remove. Okay, so here we have written Python remove banana. So the banana will get removed. Real world uses of list. Lists are everywhere. Shopping cart items, student names, product list, marks, contact list. Whenever you have multiple related values, a list is often the first choice. So, okay, congratulations everyone. Today we completed the important intermediate foundation of Python. We learned loops, for loop, while loop, break, continue, pass, nested loop, functions, parameters, arguments, scope, collections, list. These concepts are used in almost every Python project. Now, your next step is to practice. Try creating small programs, student management system like calculator, number guessing game, simple attendance system. Remember, programming is not learned by watching. Programming is learned by writing code. Thank you for watching this lecture. Keep practicing, keep learning, and I'll see you in the next Python tutorial.